the most common mistake is the distribution of the negative sign, okay? So again, when you're adding, just add the numerator. Denominators will stay the same. When you are subtracting, what must you do with the minus sign? Distribute. Otherwise, you're not going to have the right numbers. Here we go. Add or subtract accordingly. First one is 2x plus 7 all over x minus 3 plus 3x minus 10 all over x minus 3. Check out the denominator. Are they already the same? So I'm going to rewrite the denominator. They are already the same. I don't have to find anything. On the numerator, can I combine anything? Anything that's the same? Yeah. So 2x and a 3x, Keely, what would that make? Good. Then we can also combine the 7 and a negative 10, and what would that make, Chloe? Seven minus 10? Good. Then the step says factor to see if it's reducible. On the numerator, is it factorable? No. Good. On the denominator? No. So guess what? You can't reduce, so leave it. But you also need to state the restriction. What is it that x can never ever be? Right. Now that you're really good with the restriction, you can simply write it in. Okay. Number 2, 8x plus 3 all over 3x plus 4. Take away 2x minus 5 all over 3x plus 4. So look at the denominator. Bella, is the denominator already the same? Yeah, so I don't have to do anything. I'm just going to write it over. So 3x plus 4. On the numerator, I'm going to copy it over, and I'm going to write the second in a set of quantity. So minus a quantity of 2x minus 5. Why is it smarter to write the second numerator in a set of quantities? Yeah, so you don't forget to distribute this sign, the negative sign. Because if you don't distribute, then the 5 will be incorrectly written out. So on the top is 8x plus 3 minus what? 2x plus 5. Plus 5 all over 3x plus 4. Combine like terms on the top for me, Maurice. 8x and a negative 2x, what would that make?
6.
Good. Then 3 and a 5, Wyatt, what would that make? Good. All over 3x plus 4. Do we box that up? No. Can we factor the numerator? What? Can you, Ashley, tell me what to factor out?
You factor by 2, or you factor out
2. And then we are left with 3x plus 4 all over 3x plus 4. Now before I go and cancel things out, what must you do? Restriction. X can never ever be what? Good. Can you see that if you know it right away, do you have to do your work? Because by now we have practiced restrictions so much, you can just see it. But if you are still struggling, how do we find restrictions? Take the denominator and set it equal to 0. So 3x plus 4 equals to 0. Move the 4 over. That gives you a negative 4. Divide both sides by 3. That's where the negative 4/3 come from. Okay. Now, can I cancel here? This one goes to Jason. Anything that we can reduce? No. Box it up? No. Jason, consult your team. Cancel what? Thank you. The whole quantity. Final answer. What are we boxing up, Skylar?
2.
2. Beautiful. Box it up. Okay. 2 is the final answer with restriction. 3. Here we go. X squared all over 3x minus 15. Take away 25 all over 3x minus 15. Dominic, are the denominators already the same? So we're going to write it over. If we write the denominator over, Amina, what would be the numerator? Beautiful. Do we box that up? No. Can we factor out, Kylie, can we factor the numerator?
Yeah, it will be x minus 5 and x plus 5.
Good. All over. Can, Valerie, we factor out the denominator?
Yeah.
What are the factors?
3 out.
Mm-hmm.
And then x minus 5.
Good. Do we box that up? No, but before we reduce or cancel, we should state the restriction right away. What is it that x can never, ever be? This one goes to Justine.
0 and 5.
Just 5? How come the 0 is not there?
Because always 0 is always an answer.
Yeah, 3 is not a 0, so I don't have to worry about 3. Now, let's cancel.
Could you write 0 if you wanted to?
No, that would be incorrect.
What?
Okay. Can I write 0? No. Because there's nothing that you will be able to solve in the denominator that equals to 0. So when we cancel out the x minus 5 from the top and bottom, Josh, final answer.
X plus 5 over 3.
Mm-hmm. Is that denominator ever 0? No, it's a 3. Okay? Okay. Now, that's how we add or subtract rational expression if the denominators are the same. It's pretty simple. But here's the part that I want to review. Find the least common multiple or the least common denominator. Numbers 1, 2, 3, 4. Billy, help me read.
Factors. Find all common factors, list the remaining factors, and multiply them all together.
Perfect. Okay. So let me ask you this. 5 and 10. What is the least common multiple? That means, what's the least number, the smallest number that will enable you to divide 5 and also 10? Okay? No. That will enable you to divide 5 and 10, not go into 5 and not go into 10. What is it? What? It's 10. Can 5 divide by 10? No. But can 10 divide by 5? Can 10 divide by 10? Yes. So, this is a review. 1, 2, 3, 4, 5, 6, a review. So, the least common multiple would be what? 10. And here's kind of how to do it, even though you already know it. 5, can that be factor? Or is it already a prime?
It's already a prime.
It's already a prime, okay? But 10 can be factored into what two prime numbers?
5 and 2.
5 and 2 or 2 and 5. Okay. Now this is how you come up with a 10, or when it gets to more difficult numbers, this is how we do it. Can you see that there's a 5 here on the first number and there's a 5 here on the second number? You don't take both. You don't write 5 times 5 times 2. Okay? Because 5 is a shared prime number, you just take one of it. Does that make sense so far?
Yes.
2, is it in both sets? No. So you take it. Okay? If it's not in either one, then you take it. And you multiply them all together, like number 4 said. So this one is a 10. Okay? So that's how we find a common denominator later. So we are going to factor it all out. Then we're going to take, remember, if it's the same, do we take both? No, you take one of them, okay? So like 7 and 9. Is 7 factorable? No, so it's already a prime. How about 9? Yes, it's 3 and 3. So you go through each one. When I find the least common multiple, what would you take? What would you take? Is 7 in both sets? No, you take it. Times. Okay, this is the next prime number, right guys? Is 3 in both sets? No, it's only 9. So you take it. How about another 3? Is this 3 in both sets? No, so you take it. So this is the same thing as really saying 9 times what? 7, which is really?
63.
So is 63 the smallest number that is?
Yes.
Yes, that would divide 7 and divided by 9. What's the least common multiple of 2 and 3? 6. Because look, they're both prime already. So all you got to do is multiply them together. What's the least common multiple of 7 and 5? 35. Because they both are already
Prime.
right. Okay. So when you can't find anything, then you multiply the 2. Okay. 12 and 20. Take a wild guess. What's the least common multiple?
60.
60? How about 40? Would 40 work? No. 40 is divisible by 20, but is it 12? No, not nicely. Okay. So we're going to factor out the 12 and see what the common theme is. What are the prime numbers multiply give you 12? 3 times what? 4. But 4 can go a what?
2 times 2.
2 times 2. So those are all my prime for 12. Yes or no? 20, I'm going to factor that one to what?
2 and
5 is a prime, so I'll circle that up. And then 4, but 4 is not a prime, right? So 4 can go further into a 2 and a 2. Now this is where it's going to be a little bit confusing. Let's look through one at a time. And how, whoever said 60 is right, and this is how we come up with 60. Let's start with the first prime number that we see, 3. Should we use 3? Yes, because it's only by itself. Now, can you see that there are 2 2's in each one?
Yes.
Do I take all 4 of them? No. How many do I take? Just 2 of them. One set. Okay. If they are identical in each set, then I just take one set. Should I take a 5? Yes, I take a 5 because it's all by itself. So now let's multiply them together. 3 times 2 is? 6 times 2 is?
12.
12 times 5 is?
60.
So whoever says 60, you are right. Now, if you already know how to do it, do you have to do it this way? No. This is just me reminding you how and why you came up with those numbers. Okay, so that's review. Now, but in algebra, guess what we add on to your stuff?
Variable.
Variables. So, example 7, you're going to factor it out. Is it factorable?
Yes, it is.
What can you factor out? That's right. So, Stacy, when we factor up to 2, what's left?
7.
X. Good. 3x plus 21. Jonah, is that factorable?
Yeah, it is.
What are the factors? What are the factors? And times what? Thank you. Okay. Class, is that it? Is that all we can go? Yes, that means each of those now a prime. So first prime is 2. Okay. Should we take that? Yes, we're going to use it. Next, is x plus 7 also a prime? That means you can't factor anymore.
Yes.
Can we take it? Yes, we take it. Okay. Is 3 a prime? Yeah, we take it. Do I take the x plus 7 in green again? No, I already have one of those. So, let's multiply it out. I get 6 times x plus 7. Should I distribute if I want to? Sure, you could write 6x plus what? 42 if you wish, or leave it undistributed.
If you were to do that, you would, so in this case, if you do end up distributing it, it'd be 6x plus 42.
Correct.
But you won't reduce that, right?
You cannot reduce that.
Okay.
Okay. Next, 8. Find the lowest common denominator of 8, x minus 1 and x plus 2. Saxon, can I factor out x minus 1? No. So guess what? It's already a prime. Can you factor out x plus 2, Kelly? No. It's already a prime. So guess what we do when they're both prime?
Foil.
We multiply those 2 together.
So yes.
Okay. Do you have to FOIL for that one? You can. Okay. If you choose to FOIL, I would totally accept your FOIL format as long as the like terms are combined. 9. X squared minus 9. Delaney, is that factorable? What are the factors? Very good. Then 4x plus 12. Matt, is 4x plus 12 factorable?
Yeah.
What are the factors?
4 and then x plus 3.
Good. Okay, let's go through each one. X plus 3. I have one on this side, one on that side. Do I take both or just one of those? Just one of those. Okay. Then I have an x minus 3. Should I take it or not take it? Take it. Okay. How about a 4? Yes. So I'm going to stick it to the front. Do you want a FOIL or no? No. Okay, that's fine by me. Next. Okay. In your notes, these are the guidelines, guys, for when the denominators are what? Different. Okay, copy it down. I don't have this right here, so I don't have an extra worksheet, so we'll cross that out. So these are the guidelines for adding and subtracting when the denominators are totally different.
Is this on 12, please?